In this recording, we're going to work through some of these examples. Use the properties of parallelograms, rectangles, squares, and rhombi to find the missing sides. So if we look at example 1, this is a parallelogram. And one of the characteristics of a parallelogram is that their consecutive angles are supplementary. Okay? So that means the measure of angle T plus the measure of angle S equals 180. So if we want to find the measure of angle T, we're simply going to take 180 and subtract the measure of angle S, giving us 74 degrees. Example 2 looks like a square, could be a rectangle, but notice that we have a right angle here. If we have one right angle, we know if it's a subgroup of the parallelogram, we know that consecutive angles are supplementary and opposite angles are congruent. So by that logic, we know that the measure of angle S is 90 degrees. We look over here at example 3. Could be a rhombus, could be a parallelogram. Really doesn't matter, but what we do know is if it's a parallelogram or a rhombus, opposite sides are congruent. If opposite sides are congruent, their measures are the same. So the length of side NK equals 15.8. We're going to continue using properties of our quadrilaterals. This is a parallelogram. Opposite sides are congruent, which means their measures are equal. So I'm going to take my 3x minus 4, set that equal to 20. Add 4 to both sides. 3x equals 24. Divide both sides by 3, and we get x equals 8. Example 5, we have a right angle here, so that means every one of our angles are right angles, and we could solve it one of two ways. We could solve it recognizing that it's a right angle, and all right angles measure 90 degrees. And we get x equals 3, or we can use the fact that it is consecutive angles and they're supplementary. So we would have 90 plus 30x equals 180. Subtract 90 from both sides. We get 30x equals 90. Divide both sides by 30, and we get 3. So either one of those methods would work. Coming down to example 6, we have a parallelogram. We have opposite angles, and because it is a parallelogram, opposite angles are congruent, which means their measures are equal. So we set those two expressions equal to each other. We need to add 4 to both sides. Subtract 20x from both sides. 21 minus 20x is x. And so that is what x is. But notice we want to find the measure of angle F. So we're not quite finished yet. Measure of angle F equals 20 times x. So we're going to substitute the 4 in for the x. And we get 80 degrees. Coming over to example 7, this is a parallelogram. Opposite sides are congruent, which means their measures are equal. So we set this equal to each other. 2x minus 7 equals 5 plus x. I need to move my x over here. I do that by subtracting. I need to move 7 over here. I do that by adding. 2x minus x is x. 5 plus 7 is 12. But again, I want to find the length of side FG. Side FG is equal to 2x minus 7. I should say equals. I'm going to take my 12, substitute it in for my x. 2 times 12 minus 7, 24 minus 7, and you get 17. All right, now we're going to look at trapezoids. Okay, we want to find this measure here. These are consecutive non-base angles, and so they're going to be supplementary. That means the measure of angle K plus the measure of angle J equals 180. If I want to find the measure of angle K, I simply take 180 and subtract the measure of angle J. I get 100 degrees. And you would do the same thing here. Measure of angle C plus the measure of angle D equals 180. Oh, that went off the screen. Sorry about that. Measure of angle D equals 180 minus 115. So that means the measure of angle D is 65 degrees. When we move down to example 10 and 11, notice that they have marked the two non-parallel sides or legs as being congruent on both of these. So these are isosceles trapezoids. And when you have isosceles trapezoids, the consecutive base angles are congruent. In this case, angle U is congruent to angle X, which means the measure of angle U equals the measure of angle X, and in this case, 67 degrees. When we have an isosceles trapezoid, it's going to be multi-step, or let me explain it in two ways. We know that the measure of angle X plus the measure of angle W equals 180. And because it is an isosceles trapezoid, we also know that angle W is congruent to angle Z. Therefore, the measure of angle W equals the measure of angle Z. And so the way we're going to find the measure of angle Z is find the measure of angle W. Measure of angle W is going to be 180 minus 100. So it's going to be 80 degrees. And since the measure of angle W is 80 degrees, so is the measure of angle Z. So those are your trapezoids. Okay. Moving on to our kites. We are told, or we are given, that Ly is 13, and we want to find the measure of Lj. Lj is a diagonal, and we know that the diagonal that cuts to the opposite angles is bisected by the other diagonal. So that means LJ is going to equal 2 times LY. 2 times 13, and we get 26. Looking at this kite, the reason why I know it's a kite is I have consecutive congruent angles, sides. Not all 4 sides are congruent, so it's not a rhombus. Since these 2 sides are marked congruent, UT is congruent to UR. Because they are congruent, that means their measures are equal. UT is 9, so UR is also 9. For example 14, we are looking for that angle. What do we know? The sum of the angles in a kite equals 360 degrees. We know 2 of them. If we knew the measure of angle Q, we could add these 3 up, subtract it from 360. So how do we find the measure of angle Q? Notice that angle S is formed by 2 consecutive non-congruent sides, and angle Q is formed by 2 consecutive non-congruent sides. So this means angle S and angle Q are called opposite angles in the kite. And what we know about the kite is opposite angles are congruent. So that means the measure of angle Q equals the measure of angle S, which in this case is 108 degrees. So now we can easily find the measure of angle R. We're going to take 360 and we're going to subtract the sum of the 3 other angles. We have 108 plus 108 plus 78. And you plug that in your calculator and the measure of angle R is 66 degrees. Example 15, again we have a kite. We want to find the measure of angle G, and just like in example 14, angle G and angle E are opposite angles, which means the measure of angle G plus the measure of angle E, means their measures are equal, not add. Okay? So I'm going to go back to something we did way early in the semester or in the school year, and it's part plus part equals whole, only this time we have 4 parts. We have the measure of angle E plus the measure of angle H plus the measure of angle G and the measure of angle F. Because it is a kite, adds up to 360. But we know the measure of angle G and the measure of angle E, these are equal. So I'm going to substitute in measure of angle E. Measure of angle H is 99 degrees. Since these are equal, I'm going to substitute in the measure of angle E for angle G and angle F, 71 degrees, 360. I need to combine like terms, so I have 2 times the measure of angle E. 99 plus 71 will give us 170 equals 360. Subtract 170 from 360, and we get 190 degrees. Then divide by 2. Measure of angle E equals 95 degrees, which also equals the measure of angle G. So it is 95 degrees.